Thank you very much for your kind introduction. Welcome, ladies and gentlemen, to my presentation about test equipment and system components for fuel cells and electrolyzer. At the beginning, a few words about our company. Our company is located in Dresden in Germany. It was founded in the year 2000 and we started with our SOFC development in 2002. So meanwhile, it's quite a long time. And on my next pages, I would like to give you a short overview about the products we provide to our customers. The products are divided into two main groups. On the one hand, we have a process technology, starting with the heat management components. Then we have fuse processing components, followed by a burner as heat source, furnaces, and special reactors. And on the second hand side, we have fuel cell system products that are most important for us, the test tricks for fuel cells and electrolyzer, and then also the demonstration systems. And in this topic we have also all the software we need for visualization, control, or data logging, the software to control the units. Okay, on my next slides I would give you some more details about some of the components we provide. Here we have electrical air and gas heater, which are available for temperatures up to 850 degrees. They can be combined with recuperation units to save energy. And applications are mostly in test rigs where we need very flexible and precise temperature adjustment for air or gases. On the next slide here we have the heat exchangers, which are available as plate type heat exchanger as well as tube or tube bundle heat exchangers for temperatures up to 950 degrees. They are available as gas or gas water heat exchangers in a size from a few hundred watt to so far 55 kilowatts transfer rate. And applications were in fuel cell systems, reforming units, and so on. For the fuel processing, we have here at first the humidification units. We can use electrical evaporation. For low humidification rates, we can use bubbler systems, and for higher direct electrical evaporators, which are available up to 4,500 grams per hour. And in SOFC systems, it would be also possible to use thermal evaporators like heat exchanger to make steam in that case. And where the electric evaporators are also available for fuels like methanol, for example, not only for water. For the reformation, we have a reformer which can be used for natural gas as well as LPG, biogas, ethanol or methanol. They are available for all the three techniques, steam reforming, CPOX or autothermal reformer. And we are available with noble metal catalysts as well as nickel catalysts. In fuel cell systems, often it's required to use a heat source like a burner for the start, to start with the heat up of a system. At the beginning, therefore, we can use porous media burners with a high power density. And beside the start burner, it's often required to use a burner for the exhaust gas of the fuel cell, and therefore it would be suitable to use catalytic burners, which can also be used for wide modulation range, and they can also be used for low temperature levels. Beside the more or less standard components from the last slides, we can provide, using our experience, also to provide completely different kinds of reactors or containers, where we can put in all the techniques we can use for other components. So if you have a special requirement for any different reactors, you can contact us and we can see if we can provide something to you, starting from design and engineering as well as manufacturing. Okay, with this slide, it's the end of part of the process technology. On the next slides, I will follow with fuel cell test tricks. Here on this slide we have a lot of small pictures of different kinds of fuel cell test rigs we made in the last decade. So you can see there are a lot of flexibility to make different configurations. We can provide single cell test rigs, including cell housings or without cell housings, as well as test rigs for short stacks and stack modules. There are a lot of flexibility starting from the gas supply, from the fuel processing. And yeah, on the next slide I have just a few things which can be selected or modified. So here we have some different kinds of furnaces which are required if you want to use just a single cell. You can select, for example, the smallest one of furnaces at the top with inner volume of between 10 or 15 liter for quite small cell tests. Followed by the next picture with hood type furnaces, which is used most often in the past, with inner volumes between 50 and 250 liter. And beside this very common size, we can provide also much bigger furnaces, like you can see here on this slide, which can be used for complete systems or subsystems to test. Okay. Fuel cells and electrolyzer are used to produce electricity or to use electricity to make gas. The electrical power we can provide right now up to 20 kilowatt for the electrolyzer and fuel cells, and the electrical current we have realized so far is up to 600 amps. And also if you want to use fuel cells and electrolyzer in the same test rig, it's available. And also for test rigs for fuel cells we made in the past, it's possible also to retrofit these units, which can be now also used for electrolyzer. For single cells as well as for stacks, often it's required in a furnace environment to use a compression system for stack or cell, and therefore we can provide solutions up to 15 kilonewton compression force. And here we have also on the picture below one force sensor where we can accurate measure the force we use for the stack, and it's a product from our mother company called AST. Yeah. This is the last slide about the test rigs. On the next page, we come here to the software. So beside the hardware of the test rigs, it's required to have software for visualization. And here we have a graphical user interface which can be used for manual operation of a test rig, showing all the actual values and where it's possible to give all the different set points for the different components. This is for manual operation, and another program called ProControl we provide for the automatic stack testing. And if you have an own programming language or software system you want to use, there's also an OPC interface where you can have access to all the variables from the test rig, to use other software tools for visualization, control, or data logging. Beside the test rigs, we provide demonstration systems for SOFC of users. In the past, it was mainly used for research purposes, like micro CHP systems for natural gas or for biogas systems, or for other kinds of research institutes. You have here some examples on these pictures. And based on our experience in this field, we can also provide engineering services if somebody wants to build up their own SOFC system. Yeah, besides these commercial products from us, we have also some other internal development projects, and one, go to the next slide. Yeah, one topic of our research and development projects are here a system and evaluation of a SOFC system for use of liquid fuels like GTL or diesel. Therefore, we have did some tests in the last months and year, and where we had some promising results, and so this will be also one of the topics we will continue furthermore. And with this slide, I will come here to the end of my presentation. So if you have any further questions, you are welcome to contact us directly here at our booth. It's E45. And so you're welcome, and thank you very much for your attention.
Thank you very much, Dr. Sander Ruland. Are there any questions from the audience at the moment? No? Okay, so you're German-based. Are your clients also, you're mainly focused in Germany on the client side?
No, our customers are in Germany, Europe, and also all around the world. So also international visitors are welcome. And we deliver here from Germany to all over the world. Yes.
Thank you very much. Give him a big hand of applause. Thank you very much, Dr. Sander Ruland.
Thank you much.